In this video, we're going to talk about how we can combine different functions to create a new function. And we have some new notation. If I want to add two functions, f and g, to create a new function, my notation would be f plus g of x. If I want to subtract to create a new function, then I would write f minus g of x. Now, for the addition of f plus g, the order does not matter because 3 plus 2 is still 2 plus 3, it's still 5. But please keep in mind with the subtraction, order matters. If you take f and you minus g, that's going to be different if you take g and you minus f. If I want to multiply two functions together to create a new function, that's going to be f times g of x. And for that one, the order doesn't matter. F times g is the same as g times f. And then the last one is division, f divided by g. And remember, g of x cannot be equal to 0 because we don't want to divide by 0. And for division, the order matters. So f divided by g is not going to be the same thing as g divided by f. Now, to find the domain of our new functions, with the exception of the division, we'll get to that in a second. With the exception of the division, all we're going to do for all the other ones, we're just going to look to see what the domain of f is, what the domain of g is, and look to see what they have in common. And that's what this symbol means right here. I'm going to find the domain of f. I'm going to find the domain of g, and then this symbol right here that looks like an upside down U stands for the intersection. That's to show where they overlap or what they have in common. Now, that holds true for the f divided by g, for the division of two functions, with the extra rule of you have to also make sure that g of x is not equal to 0 because you can't divide by 0. Okay, so let's go to our first example. Let's see. Example 1 says f of x is going to be 5x plus 1, and g of x is equal to 3x minus 2. And we're going to find these four new functions. We're going to do this 4 different ways. So if I want to find f plus g of x, that just means I'm going to take f of x and add g of x. And then if you can, of course, simplify it. So f of x is 5x plus 1. And I want to add it to g of x, which is 3x minus 2. When I add those together, I get 8x, and then a 1 and a negative 2 gives me a negative 1. So this is my function, f plus g of x. Now my domain for f plus g of x would be where the domain of f and the domain of g intersect. What do they have in common? And if I look at my domain of f, it's just a line, 5x plus 1. So my domain for f, let's write it up here. My domain for f is all real numbers. My domain for g is also all real numbers. So they overlap with all real numbers. So my domain for f plus g is all real numbers. For f minus g of x, I'm just going to subtract g from f. So I'm going to take 5x plus 1. Now here's where students make mistakes. Be careful. When you subtract the entire function, you're subtracting the whole thing, 3x minus 2. So you have to remember to distribute your minus sign. So that's going to be 5x minus 3x, which is 2x. And then 1 minus a negative 2 gives me a 1 plus 2, which is a 3. So this is my function f minus g. And where they overlap with the domains is going to be, of course, all real numbers, right? Because my domain of f is all real numbers. My domain of g is all real numbers. So where the two overlap, what they have in common is all real numbers. For f times g, I'm going to take f, which is 5x plus 1, and multiply that by 3x minus 2. And I would have to FOIL that, right? 5x times 3x, and then 5x times minus 2, etc. I'll let you guys do that, but you would multiply that out. And then, of course, my domain, again, where they overlap, is all real numbers. So let's see. Now, here's the f divided by g, where we have that extra rule. Not only do we look to see where the domains overlap, but we also have to take into consideration the g of x, whatever is in the denominator, cannot be equal to 0. So I'm going to take f, which is 5x plus 1, and I'm going to divide by g, which is 3x minus 2. Now, typically I would say the domain of f and the domain of g are both all real numbers, so where they overlap would be all real numbers, so that would be my domain. But then I have that extra condition to watch out for. I also have to say that x cannot be equal to negative 2/3, because if I plug in negative 2/3 into this x down here in the denominator, that's going to give me 0 in the denominator, and we can't have that. So my domain for f divided by g is all real numbers except negative 2/3. So when I want to write that in interval notation, it would look like this: from minus infinity up to negative 2/3, skip over 2/3, union the negative 2/3 to infinity. Next example, we have f of x is 1 over x plus 3, and g of x is the square root of x. So my domain for f is all real numbers except for negative 3. So it would be minus infinity up to negative 3, union negative 3 to infinity. Right, because I can't plug in negative 3. I can plug in anything else, but I can't plug in negative 3 because that would give me a 0 in the denominator. My domain for g would be anything positive or equal to 0. So that would be from 0 to infinity, including 0. Because I can't plug in negative numbers for x, so that would give me a negative under the square root, but I can plug in a 0 and anything positive. So where they overlap, if I look at this on my number line, let's do the domain of f in blue, and let's do the domain of g in green. So the domain of f is everything except for negative 3, so that will be an open circle. So anything except for negative 3. The domain of g in green is anything bigger than 0 or equal to 0. So if this is 0 on my number line, it's going to be, whoops, we were going to do that in green. Hold on. Here's including 0 or bigger than 0. So where they overlap would actually be from 0 to infinity. Right? This is where they overlap, from here and over. Okay, so now, if I go back to the problem, I know what the domain is going to be, except for the f divided by g with that extra rule about the denominator being 0. But I know what all the domains are going to be for f plus g, f minus g, and f times g. It's going to be from 0 to infinity, including 0. So if I do f plus g of x, that means I'm going to take f of x and add it to g of x. So that's just 1 over x plus 3 plus the square root of x. F minus g of x is the same thing, but I subtract the square root of x. So I have 1 over x plus 3, and I subtract the square root of x, because it's f minus g. F times g of x would be 1 over x plus 3 times the square root of x, which I can write that together as one fraction as the square root of x over x plus 3. So all of these have the domain from 0 to infinity, including 0. Now when we do f divided by g, I also have to take into consideration that the denominator cannot be equal to 0. So when I do f divided by g, f is going to be 1 over x plus 3, and I'm going to divide that by g, which is the square root of x. I don't want a complex fraction, so what I'm going to do is I'm going to write this as the square root of x over 1, and I'm going to do a flip and multiply so that I write this as a fraction that is not complex. And then that's going to give me 1 over the square root of x times x plus 3 when I do a flip and multiply. So now I have to take into consideration that the denominator cannot be equal to 0. So x cannot be equal to 0 here, or x cannot be equal to negative 3. If I look at my domain, the only thing that we have to adjust is to take out including 0. For this one, it's just going to be 0 to infinity without including the 0. I can't include the 0 here because that would give me 0 in the denominator. The square root of 0 is 0, and 0 times whatever that parentheses is, the x plus 3, is going to give me 0 in the denominator. So for these here, these are all going to be the same domain. But when you do the f divided by g, or if you do it in reverse, the g divided by f, depending on what order you do it in, you also have to take into consideration that denominator.